This force sensor is measuring the weight of the water container. Now, what if I slowly place my hand into the water? When I put my hand in, I'll be very careful not to touch the bottom of the container. Now think, will the weight of the container increase, decrease, or just stay the same? Well, we can figure it out using a force sensor. For this activity, we're going to need a NovaLink data logger and the Multilab software, lab stand and clamp, a plastic container big enough to contain your hand, filled with water and attached to a string. Now in the Multilab, set the force sensor on position 50 newtons. Set the sampling rate to 10 samples per second and the number of samples to 2000. Let's begin recording in Multilab and observe the graph that shows the change in the weight of the container over time. Now watch as I slowly place my hand in the water. Look at the graph. The weight of the container increases as I submerge a greater portion of my hand. Now let's see what happens as I slowly remove my hand from the water. Notice how the weight of the container is now decreasing. Now that my hand has been completely removed from the container, let's stop the measurement. To understand what's causing the changes in weight, we're going to need some help from two great thinkers, Archimedes and Newton. According to the Archimedes principle, the force that acts upward on an object submerged in liquid is equal to the weight of the liquid displaced by the object. We call this the buoyancy force. What this means is, the buoyancy force is equal to the weight of the water displaced by my hand. The more I submerge my hand in the water, the greater the buoyancy force. As the buoyancy force increases, we observe what Newton would call an equal and opposite force acting downward. This downward force is the increase in weight measured by the force sensor, and this is precisely what we see on the graph. And to that we say, Eureka!